Next, solving integral equation by approximation method, right? So using Taylor's Maclaurin series. So first we are going to see some expansion, then we'll see the problem. First, a list of some expansion. The exponential function with base e has Taylor's series expansion e power x is equal to summation n is equal to 0 to infinite x power n by n factorial, which is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus etc. etc. It converges for all x. The natural logarithm with base e has Taylor's series expansion. First logarithm log 1 minus x expansion, which is equal to minus integral summation n is equal to 1 to infinite x power n by n, that is equal to minus x square by 2 minus x cube by 3 minus etc. etc. It converges for mod x less than 1. Second one, log 1 plus x, that is equal to summation n is equal to 1 to infinite minus 1 power n plus 1 x power n by n, which is equal to x minus x square by 2 plus x cube by 3 minus etc. etc. Converges for mod x is less than 1. The geometric series and its derivative as Taylor's series. First one, 1 by 1 minus x, that is 1 minus x power minus 1 expansion, that is nothing but summation n is equal to 0 to infinite x power n 1 plus x square plus x cube etc. etc. It converges for mod x less than 1. Then you are considering 1 by 1 minus x the whole square, right? Geometric series, right? That is 1 minus x power minus 2, that is summation n is equal to 1 to infinite n x power n minus 1, that is equal to 1 plus 2x plus 3x square plus etc. etc. So this series is converges for mod x is less than 1. Then third one, 1 minus x whole power minus 3, that is 1 by 1 minus x cube, it is equal to summation n is equal to 2 to infinite n into n minus 1 x power n minus 2 by 2, that is equal to 1 plus 3x plus 6x square plus 20x cube plus etc. etc. So this is converges for mod x is less than 1. Then binomial series, that is the power series, 1 plus x power n equal to summation r is equal to 0 to infinity ncr x power n. It converges for mod x less than 1 for any real and complex number n. When n is equal to minus 1, this is essentially the infinite geometric series mentioned in the above section, that is 1 by 1 plus x. We know 1 by 1 minus x a in the previous one, geometric series. Similarly 1 by 1 plus x. The usual trigonometric function have the following Taylor series: sin x expansion, summation n is equal to 0 to infinite minus 1 power n by 2 plus 2n plus 1 factorial x power n 2n plus 1, x minus x cube by 3 factorial plus x power 5 by 5 factorial minus etc. etc. for all x. Similarly cos x, which is equal to summation n is equal to 0 to infinite minus 1 power n x power 2n by 2n factorial 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus etc. etc. for all x. First problem. So solve g of s is equal to e power s minus integral 0 to 1 s into e power st minus 1 g of t dt. So given g of s, which is equal to e power s minus integral 0 to 1 s into e power st minus 1 g of t dt, that is equation number 1. So that is equal to e power s minus integral 0 to 1 s into expansion of e power st 1 plus st plus s square t square by 2 factorial plus s cube t cube by 3 factorial plus etc. etc. then minus 1 g of t dt. So we are using Taylor's expansion, right? So e power s minus integral 0 to 1 multiplying with s, plus 1 and minus 1 get cancelled, right? So s square t plus s cube t square by 2 plus s power 4 t cube by 6 g of t dt. This is approximately, we are taking 3 terms, right? So e power s minus we are taking s square outside, so minus s square integral 0 to 1 splitting into 3 integral t g of t dt minus s cube integral 0 to 1 t square by 2 g of t minus s power 4 integral 0 to 1 t power 6 t cube by 6 g of t dt. So we are taking c1 as a constant, that is equal to integral 0 to 1 t g of t dt, c2 integral 0 to 1 t square by 2 g of t dt, and c3 equal to integral 0 to 1 t cube by 6 g of t dt. So it will become g of s is equal to substituting these values in the above line. So g of s is equal to e power s minus s minus c1 s square minus c2 s cube minus c3 s power 4. That is equation number 2. Using 2 in 1. So we are going to use g of s value in the equation number 1, right? So left hand side becomes, so e power s minus c1 s square minus c2 s cube minus c3 s power 4, right? Minus, which is equal to e power s minus integral 0 to 1 s e power st minus 1 into e power t minus t, right? So we are substituting g of t value e power t minus c1 t square minus c2 t cube minus c3 t power 4 into dt minus s c1 s, because e power s on the left hand side, right hand side get cancelled, minus s on the left hand side and right hand side get cancelled. So remaining terms minus c1 s square minus c2 s cube minus c3 s power 4 on the left hand side. From that you take minus s outside, right? c1s plus c2 s square plus c3 s cube, which is equal to, on the right hand side you are having s inside the integral, take it outside, minus s integral 0 to 1 e power st minus 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt, right? So yes, minus s on the left hand side of the equality and the right hand side of the equality get cancelled. So remaining you are having c1s plus c2s square plus c3s cube, which is equal to integral 0 to 1 e power st into e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt minus the second term, right? Minus 1 into, that is integral 0 to 1 in 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt. So using the Taylor's expansion for e power st, now we are going to use that inside the integral, right? c1s plus c2s square plus c3s cube integral 0 to 1 plus st plus s square by s square t square by 2 s cube t cube by 6 approximately e power st expansion. Then remaining term e power t, the terms, complete terms, e minus t minus c1 t square minus c2 t cube minus c3 t power 4 dt minus integral 0 to 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt. So multiplying each and every terms and expand, right? Separate integral, right? So we'll have a large number of terms here, right? Integral 0 to 1 e power t dt plus s into integral 0 to 1 t e power t dt plus s square by 2 integral 0 to 1 t square e power t dt plus s cube by 6 integral 0 to 1 t cube e power t dt minus integral 0 to 1 t dt minus s into integral 0 to 1 t square dt minus s square by 2 integral 0 to 1 t cube dt minus s cube by 6 integral 0 to 1 t power 4 dt minus c1 into integral 0 to 1 t square dt minus sc1 integral 0 to 1 t cube dt minus s square by 2 c1 integral 0 to 1 t power 4 dt minus s cube by 6 c1 integral 0 to 1 t power 5 dt minus c2 integral 0 to 1 t cube dt minus sc2 integral 0 to 1 t power 4 dt minus s square by 2 c square c2 integral 0 to 1 t power 5 dt minus s cube by 6 c2 integral 0 to 1 t power 6 dt minus c3 integral 0 to 1 t cube dt minus sc3 integral 0 to 1 t power 5 dt minus s square by 2 c3 integral 0 to 1 t power 6 dt minus s cube by 6 c3 integral 0 to 1 t power 7 dt. Then the last one minus integral 0 to 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt. So this expansion, there are 4 into 4, 16 terms, right? We have to multiply and separate the integral in the first step. From the first step we will get this one, right? So that is equal to integral 0 to 1. So we are grouping e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt minus integral 0 to 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt. Then s term, taking s outside plus s into integral 0 to 1 t e power t dt minus integral 0 to 1 t square dt minus c1 integral 0 to 1 t cube dt minus c2 integral 0 to 1 t power 4 dt minus c3 integral 0 to 1 t power 5 dt. Next s square by 2 term. We are grouping all those things, right? So integral 0 to 1 t square e power t dt minus integral 0 to 1 t cube dt minus c1 into integral 0 to 1 t power 4 dt minus c2 integral 0 to 1 t power 5 dt minus c3 integral 0 to 1 t power 6 dt. Next s cube by 6 terms, and we are grouping all the s cube by 6 terms, right, which are having s cube by 6. So s cube by 6 into integral 0 to 1 t cube e power t dt minus integral 0 to 1 t power 4 dt minus c1 integral 0 to 1 t power 5 dt minus c2 integral 0 to 1 t power 6 dt minus c3 integral 0 to 1 t power 7 dt. So that is equal to, so first two terms integral 0 to 1 e power t minus c1 t square minus c2 t cube minus c3 t power 4 dt, and the second term get cancelled, both are same. So remaining you are having s term, first s into integral 0 to 1 t e power dt can be written as derivative of e power t minus t square dt integral is t cube by 3 lower limit 0 upper limit 1, t cube integral is t power 4 by 4 minus c1 t power 4 by 4 lower limit 0 upper limit 1, then t power 4 integral is t power 5 by 5 c2 t power 5 by 5 lower limit 0 upper limit 1, then integral t power 5 is t power 6 by 6 minus c3 t power 6 by 6 lower limit 0 upper limit 1, then s square by 2 term plus s square by 2 integral 0 to 1 t square e power t dt can be written as derivative of e power t, then again integration of t cube t power 4 by 4 0 to 1, then t power 4 integral is t power 5 by 5 minus c1 t power 5 by 5 lower limit 0 upper limit 1, then t power 5 integration is t power 6 by 6 minus c2 t power 6 by 6 integral, so lower limit 0 upper limit 1, then t power 6 integral is t power 7 by 7 minus c3 t power 7 by 7 lower limit 0 upper limit 1, then s cube by 6 term, right, into integral 0 to 1 first term e power t dt can be written as derivative of e power t, so t cube derivative of e power t, t power 4 integral is t power 5 by 5 minus t power 5 by 5 lower limit 0 upper limit 5, then t power 5 integration is t power 6 by 6 minus c1 t power 6 by 6 lower limit 0 upper limit 1 minus c2 t power 6 integration is t power 7 by 7 minus c2 t power 7 by 7 lower limit 0 upper limit 1, then last one t power 7 integral is t power 8 by 8 minus c3 t power 8 by 8 lower limit 0 upper limit 1. Substituting all the values, right, so you will get s into t e power t, right, the lower limit 0 upper, here first term we are using u dv formula, integral u dv is equal to uv minus integral v du, right, t derivative of dt, u is t, v is e power t, uv t e power t lower limit 0 upper limit 1 minus integral v du integral 0 to 1 e power t dt, that is the first term. Then remaining term we are substituting the values, only upper limit you will get, right, because lower limit all are 0, so you will get minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6, this is s term, then s square by 2 term into, again you are using first for the first integral u dv, integral u dv is equal to uv minus integral v du, here u is a t square and v is e power t, so uv t square e power t integral lower limit 0 upper limit 1 minus integral v du integral 0 to 1 e power t du derivative of t square 2t dt, then substituting the upper limits for remaining terms minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7, then s cube by 6 term, so again we are using u integral u dv, here u is t cube and v is e power t, so uv t cube e power t lower limit 0 upper limit 1 minus integral v du integral 0 to 1 e power t derivative of t cube 3t square dt, then remaining term substituting the upper limits, right, minus 1 by 5 minus c1 by 6 minus c2 by 7 minus c3 by 8. So s into, so we are grouping all those things and substituting the upper and lower limit. So second level integral e power t is e power t, all we are substituting, right? So we will get s into e power 1, upper limit, lower limit e power 0. So minus e power t 0 to 1, lower limit and upper limit. Right? So here t e power t, so upper limit 1 into e power 1 and second term 0 minus e power t, integral e power t dt is, so e minus e power t, lower limit 0, upper limit 1, then remaining all these terms are same. Then plus s square by 2, first term e power 1, second term minus 2, right? E power t 0, lower limit, upper limit 1, remaining term as it is. Then s cube by 3, s cube by 6, first e power 1, then minus 3 into integral 0 to 1 t square, derivative of e power t, then remaining term as it is, right? Here minus 2 into integral t, derivative of e power t, the second term, right? So substituting the values, e power 1 minus e power 1 plus e power 0 minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 e power 1 minus 2 t e power t 0 to 1 minus integral 0 to, again we are using integral u dv formula, right? E power t dt minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7 s cube by 6 e power 1 minus 3, again we are using uv formula, integral u dv e power t t square minus integral 0 to 1 e power t 2t dt minus 1 by 5 minus c1 by 6 minus c2 by 7 minus c3 by 8. So that is equal to s into 1 minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 into e power 1 minus 2 e power 1 plus 2 into integral 0 to 1 e power t dt minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7 plus s cube by 6 into e power 1 minus 3 e power 1 plus 6 into integral 0 to 1 t, derivative of e power t, minus 1 by 5 minus c1 by 6 minus c2 by 7 minus c3 by 8. That is equal to s into 1 minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 e power 1 minus 2 e power 1 plus 2 e power t, right? The integral of e power t, lower limit 0, upper limit 1, minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7 plus s cube by 6 e power 1 minus 3 e power 1 plus 6 into t e power t u dv, integral u dv formula, lower limit 0, upper limit 1, minus integral 0 to 1 e power t dt minus 1 by 5 minus c1 by 6 minus c2 by 7 minus c3 by 8. That is equal to s into 1 minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 e power 1 minus 2 e power 1 plus 2 e power 1 minus 2 e power 0, substituting upper and lower limit here, minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7 plus s cube by 6 e power 1 minus 3 e power 1 plus 6 e power 1 minus 6 e power t, lower limit 0, upper limit 1, minus 1 by 5 minus c1 by 6 minus c2 by 7 minus c3 by 8. So s into 1 minus 1 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 e power 1 minus 2 e power 1 plus 2 e power 1 get cancelled, e power 0 1, so minus 2 into 1 minus 2 minus 1 by 4 minus c1 by 5 minus c2 by 6 minus c3 by 7 plus s cube by 6 e power 1 minus 3 e power 1 plus 6 e power 1 minus 6 e power 1 plus 6 e power 0, substituting upper and lower limit here, minus 1 by 5 c1 by 6 minus c2 by 7 minus c3 by 8, which is equal to s into, so we are taking LCM for the first two term, 3 is the LCM, 3 minus 2, 2, 2 by 3 minus c1 by 4 minus c2 by 5 minus c3 by 6 plus s square by 2 e1 minus we are taking LCM bar, the minus 2 and minus 4, 4 is the LCM, right? 4 2s are 8 minus 1 minus 9 by 4 minus C1 by 5 minus C2 by 6 minus C3 by 7 plus SQ by 6. So here plus 6 e power 1 minus 6 e power 1 get cancelled. So minus 3 e power 1 plus e power 1 minus 2 e power 1. 6 into e power 0, that is 6 into 1, 1. So minus 2 e power 1 plus 6 minus 1 by 5 minus C1 by 6 minus C2 by 7 minus C3 by 8. That is equal to S into 2 by 3 minus C1 by 4 minus C2 by 5 minus C3 by 6 plus S square by 2 e power 1 minus 9 by 4 minus C1 by 5 minus C2 by 6 minus C3 by 7 plus SQ by 6 into minus 2 e power 1 plus 29. We are taking LCM 5 6 are 30 minus 1 29 by 5 minus C1 by 6 minus C2 by 7 minus C3 by 8. So we have separated S term, S square term, S cube term, right? Therefore C1 S plus C2 S square plus C3 S cube equal to right hand side as it is. Now we are going to comparing the coefficient of S square and S cube on both sides. So C1 equal to on the left hand side S coefficient, right hand side S coefficient 2 by 3 minus C1 by 4 minus C2 by 5 minus C3 by 6. That is equation number 3. Then C2, that is S square term coefficient on the left hand side. Right hand side you are having 1 by 2 into e power 1 minus 9 by 4 minus C1 by 5 minus C2 by 6 minus C3 by 7. That is equation number 4. C3, the coefficient of S cube on the left hand side, which is equal to S cube coefficient on the right hand side, 1 by 6 into minus 2 e power 1 plus 29 by 5 minus C1 by 6 minus C2 by 7 minus C3 by 8. That is equation number 5. 3 implies C1, we are taking all the C terms to the left hand side. C1 by 4 plus C2 by 5 plus C3 by 6 equal to 2 by 3. That is taking first C1 terms, grouping first 2 terms. 4 is the LCM. 4 C1 plus C1, 5 C1 by 4 plus C2 by 5 plus C3 by 6 equal to 2 by 3. So taking LCM, right, and simplifying, you will get 150 C1, right, plus 24 C2 plus 20 C3, which is equal to 80. That is equation 3a. Similarly for the second term, we are grouping C2 terms, right. We are taking C1 C2 C3 to the left hand side. 2C2 plus C1 by 5 plus C2 by 6 plus C3 by 7 equal to E minus 9 by 4. So that is equal to, that implies C1 by 5 plus 13 C2 by 6 plus C3 by 7 equal to E minus 9 by 4. So we are substituting E value also, right. You can substitute the E value and simplify. 42 C1 plus 455 C2 plus 30 C3 equal to 98.28 4a. Similarly, simplifying the fifth equation, so substituting the value of E also, so you will get 56 C1 plus 48 C2 plus 2058 C3, which is equal to 122.304. That is 5a. Solving 3a, 4a and 5a by matrix method. The 3 system of linear equation can be represented by the matrix as follows. We are taking the coefficient of C1, C2, C3, right, for the all the 3 equations in the matrix. That is approximately. Now first row we are dividing the first row by 150. So replacing the first row. So 155 151, 24 5 150 0.16, 20 by 150 0.133, 80 by 150 0.533. Remaining rows are as it is. R2 is R2, R3 is R3. Next, this is equal to R1 is R1, same. R2 is minus 42 into R1 plus R2. So minus 42 into R1, 42 minus 42, 0. So 42 into 0.16, then 455, right. So adding plus 455, 448.28 you will get. Similarly, you will do all these things, so you will get this matrix 24.414, 75.894. Similarly, R3 is can be minus 56 into R2, R1, then plus R3, add R3. So you will get the last row 0, 39.04, 2050 minus 0.52, 92.456. Then R1 is R1, R2 is R2 by 448.28. So you will get the second row, and third row is as it is, right? So just simplification only, that is row diminishing method we are using, right? Next R1 is R2 R3, right? R2 is R2, R3 is minus 39.04 into R2 plus R3, right? So we are making 1 0 0, that is unit matrix. That is what we are doing, right? R1 is R1, R2 is R2, R3 is R3 divided by 2048.45. So we need 1 there, that is why. So grouping C3 is equal to 0.041619, that is 6. C1 plus 0.45, Z3 is equal to 0.546, because the last row, so this matrix into C1, C2, C3, right? That is column matrix. You are multiplying, then you will get C3, last one, right? C3 equal to 0.0419. Then from the first one, C1 plus 0.045, C3, which is equal to 0.506. That is equation number 7. Then C2 plus 0.55, this is from the second row. C3 is equal to 0.6198. So using 6 and 7, C1 which is equal to 0.506 minus 0.00189, 0.50411. 6 and 8, C2 is equal to 0.169 minus 0.002305, which is equal to 0.1667. Then from 2, the solution of 1 is given by g of s is equal to e power s minus s into c1, s square minus c2, s cube minus c3, s power 4. That is equal to e power s minus 0.50411 s square minus 0.1667 s cube minus 0.0419 s power 4. Thanks.